All right, let's talk about something that's absolutely everywhere, but almost completely invisible. I'm talking about the data block. It's this unsung hero that honestly makes our entire digital world work, from the phone in your hand to the biggest data centers on the planet. So yeah, let's dive right in.
So let's kick things off with a big question. Think about it. We're all constantly creating, saving, and sending just insane amounts of information. Trillions and trillions of bits flying around every second. How on earth do our devices handle this incredible flood of data without just grinding to a complete halt?
Okay, picture this. You've got a giant pile of sand you need to move. Are you going to do it one single grain at a time? No way. It'd be impossibly slow, right? You'd be there forever. What you'd actually do is grab a bucket. With a bucket, you can move these big, standard-sized chunks quickly and efficiently. And believe it or not, that simple idea is the key to how computers handle pretty much everything.
And that's a perfect lead-in to our first big idea here, moving digital sand. Because, in the digital world, our sand is just bits and bytes. And to move it around, we absolutely need a super efficient bucket.
Now here's the really fascinating part. The biggest problem, the real bottleneck, isn't the data itself, it's the overhead. And what I mean by that is all the background work your computer has to do every single time it reads or writes something. Think of it like this. Every single trip to your hard drive to grab data costs time and energy. The whole game is about making as few trips as possible. So what is this digital bucket? Well, it's called the data block. And it is a beautifully simple, totally elegant solution to that huge overhead problem we were just talking about. So here's the technical breakdown. A block is just a sequence of bytes, or bits, that has a fixed length. Your computer, it doesn't really see individual tiny bits. Instead, it groups them all up into these neat little packages, these blocks, and then it handles each one as a single unit. It's our standardized, perfectly sized digital bucket.
And this simple idea? Oh, it has some huge benefits. By moving data around in these chunks, the computer just slashes the number of operations it has to do. That cuts way down on the overhead, which, you guessed it, speeds everything up a lot. Plus, it helps organize all that data super efficiently on your storage devices.
And listen, this isn't some high-level abstract concept that only matters in giant data centers. No. The device you're watching this on right now is reading and writing data in blocks. It's happening constantly, right under the hood. It's a totally universal principle in all of modern computing.
In fact, you find blocking pretty much anywhere data is stored. We're talking old-school magnetic tape, classic hard disks, the super-fast NAND flash memory in your SSDs and USB drives. Heck, even those old CDs, DVDs, and Blu-rays you might have in a box somewhere. They all rely on this fundamental idea of block.
So how big is one of these digital buckets anyway? Well, the size can definitely vary, but a really common size, especially on systems like Linux, is 4096 bytes, or 4 kilobytes. It turns out that's a great sweet spot that balances efficiency whether you're dealing with tiny files or massive ones. But as you might guess, no solution is ever perfect. Having this fixed-sized bucket, well, it creates its own unique set of problems. And that brings us to our next chapter, blocks, files, and waste. And here's the million-dollar question. Your files come in every size imaginable, right? A tiny text file could be just a few bytes, a video could be gigabytes. So what happens when the amount of sand you have doesn't perfectly fill up the bucket?
Well, that leads to a little problem called internal fragmentation. Any space left over inside a block is just wasted. Gone. You can't use that empty bit for another file or anything. It's just empty. This leftover space even has a name, slack space.
And this table here just lays it all out perfectly. Let's stick with our 4096 byte block size. Look at that logo.png file. It's only 100 bytes, but it has to take up an entire 4096 byte block. That means we're wasting almost 4 kilobytes of space for a tiny little file. The Word doc is a bit better, but still wastes over 3 kilobytes. The only one that's perfect is the video file, and that's just because it happens to be an exact multiple of the block size. Zero waste there, but that's pretty rare.
And just to show you how real this is, here's a little snippet of Python code. You don't even have to be a programmer to get this. You can see right there, the code literally says the block size is 4096. And then the very next line says, go read one block from the file. It's a direct, explicit instruction to go grab one of those digital buckets.
Okay, so we're wasting all this space. What's the fix? Well, the good news is that engineers are always coming up with clever new solutions. And that leads us to our final section, smarter data storage.
Yeah, the story definitely doesn't end with a bunch of wasted space. Modern file systems are getting smarter all the time, with all these new techniques designed specifically to chip away at that problem and make storage way more efficient.
And here are just a few of those really clever tricks. You've got block suballocation. Think of that like putting little dividers inside a mostly empty bucket so you can fit a bunch of smaller things in there. Then there's tail merging, which is super smart. It takes the leftover tails from several different files and packs them all together into one shared block. And then you have some really advanced file systems like ZFS that can actually use different size blocks, choosing a small, medium, or large bucket depending on what kind of data it's storing. Pretty cool, right?
So when you boil it all down, the humble data block is it's a masterpiece of simple, effective engineering. It's totally invisible to most of us, but it is the absolute bedrock that our entire digital world is built on.
And that leaves us with one last thing to think about. We are creating more data now than at any point in human history, and that's not slowing down. It's accelerating. So as our need for storage just continues to explode, how does this fundamental building block have to change? What does the data block of the future even look like?